Hello, everyone. Ayong adlaw, and of course to our dear professor, Dr. Remilo Guarda. My name is Cherryl B. Luga, and in this video presentation, I'm going to discuss to you about regular polygons. This is chapter 10 of Geometry 4th edition by Bartlett Rich and Christopher Thomas. My main focus is regular polygons, and my partner, Miss Roslyn Gallego, will discuss about circles. Okay, let me start my presentation by giving you the definition of a regular polygon. So, a regular polygon is an equilateral and equiangular polygon. So, the examples of regular polygons are square, equilateral, triangle, etc. In regular polygons, not only are the sides congruent, but so are the angles. So the center of a regular polygon is this common center of its inscribed and circumscribed circles. So from the illustration below, this shows an inscribed and circumscribed circle. So center O is the center of the polygon in the inscribed circle. Center P is also the center of the polygon and the circumscribed circle. So a radius of a regular polygon is a segment joining its center to any vertex. So as you can see on the illustration, the line segment FD is an example of a radius of a regular polygon. We can also create another radius by connecting point F to any of the vertices. Line segment FC, for example, this can also be created if we connect point F to C. So we can create a radius and the name of it will be the line segment FC. We can also create another line segment FB, and that is also a radius FA, FE, and so on. A radius of a regular polygon is also a radius of the circumscribed circle. So from the illustration, line segment PN is the radius of the polygon in the circumscribed circle. PM, we can also consider PM as the radius of our circumscribed circle as well as our regular polygon. Okay. A central angle of a regular polygon is an angle included between two radii drawn to successive vertices. An apothegm of a regular polygon is a segment from its center perpendicular to one of its sides. An apothegm is also a radius of the inscribed circle. Okay, from the illustration, PM and PN are the two radii joining the vertices of the polygon. Thus, a central angle is formed. The name of our central angle is angle MPN. PQ from from the first figure and OP from the second figure are the apothegms. OP is also the radius as well as the apothegm of the inscribed circle. So as you can see on the second figure, take note that PQ in the first figure is only an apothegm and but not the radius since the circle is circumscribed. All right, now let's go to regular polygon principles. Okay, first principle, if a regular polygon of n sides has a side of length s, the perimeter is p is equal to ns. A circle may be circumscribed about any regular polygon. Third principle, a circle may be inscribed in any regular polygon. In the fourth principle, we have the center of the circumscribed circle of a regular polygon is also the center of its inscribed circle. Fifth principle, we have an equilateral polygon inscribed in a circle is a regular polygon. Sixth principle, we have radii of a regular polygon are congruent. Seventh principle, we have a radius of a regular polygon bisects the angle to which it is drawn. The eighth principle, apothems of a regular polygon are congruent. Ninth principle, an apothem of a regular polygon bisects the sides to which it is drawn. And then for the last principle, we have for a regular polygon of n sides, each central angle C measures 360 degrees divided by n. And here is the number of sides. And then for each interior angle I, it measures n minus 2 times 180 degrees divided by n, and each exterior angle E measures 360 degrees over n. So take note that the central angle and the exterior angles have the same measures. So these are the formulas to find the measures of each of the angles given a regular polygon. So for us to better understand the last principle, I have here an illustration. On the screen, you can see a regular polygon A, B, C, D, E, and the measure of angle AOB. Take note that in the illustration, it is marked as as C means that this is the central angle. So the measure of angle AOB is equal to the measure of angle ABS. ABS here is our exterior angle. So to find its measurements, simply divide 360 degrees by 5 since our given polygon is a pentagon and it has 5 sides. So 360 degrees divided by 5, that will give us a measurement of 72 degrees. Now, for us to find the measure of angle ABC, use the formula n minus 2 times 180 degrees over n. So just substitute the number of sides, which is 5. So that will give us 5 minus 2 times 180 degrees divided by 5 is equal to 108 degrees. Now, adding the measurement of angle ABC plus the measurement of angle ABS, that is equal to 180 degrees. Now let's have 10.2, the relationships of segments in regular polygons of 3, 4, and 6 sides. In a regular hexagon, square, and equilateral triangle, special right triangles are formed when the apothem R and a radius r terminating in the same side are drawn. So in the case of the square, we obtain a 45 degree, 90-degree triangle, while in the other two cases, we obtain a 30, 60, 90-degree triangle. Now, the formulas in the figures relate the lengths of the sides and radii of regular polygons. So in our first illustration, this is a regular hexagon. And as you can see there, to find the value or to find the value of our S or the length of the sides, this is equivalent to R, capital R in the illustration. Capital R is the radius of our regular hexagon. So they are equivalent. Now, for us to find the apothem or small letter r, the formula to be used is 1 half r square root of 3. Now, next is the square. So for us to find the measurement of the length S, so the formula is S is equal to R square root of 2. And for us to find the apothem, that is the formula to be used is R is equal to 1 half S or 1 half R square root of 2. Now for the equilateral triangle, as you can see on the illustration, to find the measures of the lengths and the radii. So these are the formula to be used. So S is equal to R square root of 3. H, this is the altitude of our triangle. So H is equal to R, that is the apotem, plus R, or the radius. Again, the apotem plus the radius is our altitude. And apotem, for us to find the measurement of our apotem R, the formula is 1/3 H, and the radius is equal to 2/3 of our H, and R, or the apotem, another way of finding its measurement or finding its value is R is equal to 1/2 times the radius. Now let's have the area of a regular polygon. So the area of a regular polygon equals 1/2 the product of its perimeter and the length of its apotem. Okay, the area of a regular polygon equals 1/2 the product of its perimeter and the length of its apotem. Now from the figure, by drawing a radii, we can divide a regular polygon of n sides and perimeter P is equal to ns into n triangles. Each area is equivalent to 1/2 rs. Hence, the area of the regular polygon is n times 1/2 rs, or 1/2 nrs, or 1/2 pr. Or area of a regular polygon is equivalent to 1/2 nrs, or 1/2 pr. Okay, now let's have the ratios of segments and areas of regular polygons. So a regular polygon having the same number of sides are similar. Corresponding segments of regular polygons having the same number of sides are in proportion. Segments here include sides, perimeters, radii, or circumferences of circumscribed or inscribed circles and such. Areas of regular polygons having the same number of sides are to each other as the squares of the lengths of any two corresponding segments. Okay, so before I end my presentation, so let me leave you a quote by Plato. So geometry existed before creation, and that's gonna be all. Thank you for watching.